So here I quickly want to go over and clarify how we determine whether or not a moment is moving in a clockwise direction or in an anti-clockwise direction. I hope it goes without saying that clockwise is following the numbers in ascending order on the clock face, and anti-clockwise is going in the reverse opposite direction. So I've got a clockwise on the left and anti-clockwise on the right. So I do want to go through a few examples here. I've got 3 of them, some typical things that you might see and how to determine the direction of the moment. So I'm actually going to do this physically, and I'm going to use a pencil or a chopstick, and that will help to determine what direction the moment generated by the force will have. So I'm just going to put the pencil here. In this case, the perpendicular, the dotted line, is going to be represented by the pencil. The key thing here is that I'm going to hold the pencil in place, in position, wherever my pivot point is, wherever I'm going to take moments from. So here I'm holding it in place, and I'm just going to simulate the direction of the force. So the force is moving in this direction, and the turning effect it has on the pencil is that it's turning clockwise. This force is producing a clockwise moment. In your calculations, this should be a positive value. Okay, let's try an example that will have multiple forces. So here, the pivot point hasn't been specified, but I like to make it really clear on the diagram. We'll go for this support point on the left, and I'm just going to draw a big circle or a thick dot just to show exactly where I'm taking moments from. So if I was going to run the simulation, I'm going to put the pencil exactly where the rod would be, so it's going to be horizontally, and I'm going to hold it tight right at this pivot point, and I'm going to just show what each of these forces will do. So the force R2 is going to have an anti-clockwise effect on the rod. It's turning it anti-clockwise. The weight, the 5 newtons, has a clockwise effect on the rod. These will have different directions if I was taking moments from a different place. And just to reinforce that the moment from R1, the moment if the force goes through the pivot point, is 0. It doesn't have a turning effect. It has a lifting effect, but moments are all about turning effects. And I'll just do one more so we can see what happens when there's quite a few forces involved. One mistake that students make is that they think all forces going down are going to be the same circular direction, the same clockwise or anti-clockwise direction, which isn't quite right. Let's have a look at this. I'm going to move my pencil in place. Just going to lock it in with my finger on the pivot point. So R1 is going to have a clockwise effect. 7 newtons is having an anti-clockwise effect. It's moving the pencil in an anti-clockwise direction. 10 newtons is going to have a clockwise effect. It's moving the pencil in a clockwise direction. So if you notice, the 10 newtons and the 7 newtons were both going down, but one was clockwise while the other was anti-clockwise. You can do this physically yourself for each question that you're working with. Just hold a pencil or your pen right up in front of you on top of your diagram and just run through. Or you should be able to visualize this in your head as well. I'm not a fan of learning rules. I would more like you to visualize and understand the concept of why a force is going to produce a moment in a particular direction, and hopefully the demonstration is going to help you to get an understanding of that. But here are 4 examples or 4 cases of a direction of forces and the direction of the moment that they produce.